For our sustainable building tour, we chose the Harris A. Smith Packaging Science Building since it was awarded LEED Gold certification, and we wanted to investigate all of the building's features that led to this high certification level. First, let's introduce our team. I'm Daniel Deary.
I'm Matt Brantley. And I'm John Bell.
And we're excited to show you the sustainable features we've discovered both inside and outside of this building. This is the first LEED Gold building on Clemson's main campus, and at its time of certification, it was one of only 8 LEED Gold buildings in the entire state of South Carolina. Construction began in 2007 and the project was completed in 2009. Then the project was later awarded the LEED Gold certification in March 2010.
The Packaging Science Building is pedestrian friendly due to its convenient location to the campus as well as the bike racks. The building also has an area in the back where electric vehicles can charge. The bike racks and charging station encourage people to use other means of transportation than vehicles that release emissions into the air. Motor vehicles emit millions of tons of pollutants into the air every day and are the single largest contributor of ground level ozone, which is a major component of smog. Those pollutants are greatly reduced by either riding a bike or driving an electric vehicle.
All the exterior lighting around the building is directed towards the ground in order to minimize light pollution. Light pollution obscures the stars in the night sky for city dwellers, interferes with astronomical observatories, and like any other form of pollution, disrupts ecosystems and has adverse health effects. The Smith Building has a very high solar reflectance index, meaning it reflects light so that the heat does not build up. This awning over the walkway, for example, is made of materials with high solar reflectance.
These windows are known as solar band windows, and they transmit almost 50% less total solar energy than that transmitted by standard glass. The windows filter out most light in the UV spectrum while allowing visible light into the building.
The fins around these windows and these large trees that were planted around the building also add to the solar reflectance of the building. The fins help to minimize the glare and keep the sunlight away from the windows and from entering the building most directly. The large trees provide shade to keep the temperature of the building down in the summer, and in the winter, when they lose their leaves, they allow for the sunlight to help heat the building.
As you enter the building, you walk over a doormat that helps to control all allergens and dust coming through the door. The grate, which acts as a doormat, allows all the harmful particles to settle to the bottom of the floor, which in turn keeps the particles out of the building. This helps to keep people in the building from getting sick or even the pollutants from harming any materials in the building over time.
More than 40% of the construction materials were extracted, harvested, or recovered and manufactured within 500 miles of Clemson, and 30% are recycled. Included in this 30% is the structural steel, which can be seen here. The structural components in the ductwork is exposed in most parts of the building, which eliminates the use of materials in the ceilings that could absorb heat and increase the amount of energy needed to heat or cool the building. The majority of the floors in the building are uncovered concrete slabs. This eliminates the use of carpet, which is a material that is very difficult to recycle. It is estimated that nearly 5 billion pounds of carpet end up at landfills each year. Fly ash was also used in the concrete in this building, which cuts down on the high polluting process of cement production by using a recycled material as an alternative to some of the cement in the concrete.
Another innovative feature to this building is the automatic light sensors in all the rooms and bathrooms. These motion sensors pick up activity in the room and activate the lights. This is beneficial so that when someone is not in the room, the lights will automatically turn off. One of the areas that benefit the most is the bathroom. In most standard buildings, the lights in the bathroom stay on all the time. But with the automatic sensors, the lights turn off after a certain period of time, thus saving lights, energy, and money.
All of the components that involve water in the Packaging Science Building use 44% less water than the conventional fixtures used in a standard building. The toilets also have a two-flush feature.
Hey!
Oh, sorry, my bad. The toilets also have a two-flush feature that, depending on the use, can help cut down on the use of water. If you lift the handle up, a smaller amount of water is used for liquid waste, compared to where if you were to push the handle down for solid waste. By doing this, a substantial amount of water is saved when only a small flush is needed for liquid waste. Dry erase paint was used on select walls in all of the classrooms and on the walls outside of each office to provide an area where notes could be written. By using dry erase paint, the production of dry erase boards decreased, as well as the usage of materials that go into making a dry erase board.
90% of the rooms in this building have views outside, which has been proven to increase productivity of the building users. In fact, we use this sustainable feature to our advantage and planned our entire building tour in this room, so we know that we'll make an A. In this second floor classroom, these large windows allow for daylight harvesting, which is a control system that reduces the amount of artificial lighting in the building interiors when natural daylight is available in order to reduce energy consumption. And this concludes the tour of the building. We hope you learned something about the sustainable features of the building.
Hey, have y'all seen my bike?